I'm Kathyrn McKinley. I'm a principal researcher at Microsoft in Redmond. My research area is programming language implementation. I try to make software better, faster, more efficient, energy efficient, higher performance, and correct. Hardware is in a very disruptive period, the end of Dennard scaling, which means that hardware you note here, hardware is getting faster. Instead, we get more transistors, but what do? So now what we're seeing is specialization in hardware, which is FPGAs or specialized processors, or combining big and little processors together, a big, powerful, fast processor with a very energy efficient processor. So software has had an abstraction that all hardware is about the same and one thread of execution. So in order to make software port to different versions of crazy hardware or different generations of hardware as we go through this disruptive period, the software systems are not prepared for this. And so my research is targeting both how you do that as a software system, but also programming abstractions that let you trade off quality for energy efficiency, let you reason about the fact that sensor data is not correct, and how do you deal with these inaccuracies in a programming model that you don't need a PhD in statistics or computer science in order to use. So we have some very interesting insights about what kind of hardware is best for interactive applications. So where the industry has been very driven by the capabilities of hardware in the past, and we thought that this hardware disruption was only going to bring us pain. If you're optimizing for both average and tail latency, which means that what you perceive as a user is a consistent latency and no long ones, then you actually want heterogeneous hardware, because you want to take the things that don't run or don't need very much power or performance, you want to put them on a little bitty processor, and the work that's very hard to do by your deadline, you want to put that on the high power process, and you get a whole better system if you can organize all of that. One of the things that's so important is programmability, how you get computers to do useful stuff. And that in terms of innovation, it's often the applications that have driven both programming language, hardware, and other kinds of innovations, and that if we would embrace making things more programmable instead of focusing on ourselves, but focusing on people who have problems, that we could get further faster.